Okay, so in this video, we're going to be looking at the domain of a vector valued function and how to find it. So the basic idea here is that we're going to find the domain of each component, and then we're going to see where those intervals overlap with each other. So let's think about the domain of our x component. In this case, this is going to apply to all real numbers, because sign is always defined. Then let's look at our y component. In this case, this is going to be defined everywhere except at -1, or sorry, at +1. So -∞ to 1, union 1 to infinity. And then we're going to look at the domain of our z component. And log has an asymptote. In this case, it's going to be at 5. And so then the question then is this going to open to the right and be bigger than 5, or is it going to open to the left and be for values less than 5? And you can easily see if you graph this, if you're not completely certain, that it's going to be defined from -∞ to 5. So normally we would expect it to be from 5 to infinity if this was x minus 5, and open to the right. But in this case, because it's 5 minus x, it's going to open in the other direction. We're going to need x to be smaller, values smaller than 5 for this to be defined. So now we have to figure out where do these overlap. And so one way of doing that would be to draw the intervals. So for instance, our first number line is going to be all real numbers. So that's in our x direction. In our y direction, we're going to go from -∞ to 1, and then we're going to pick up again at +1 and go forever. So we have a 1 that is not defined. And then for the z direction, we're going to go from -∞ up to and not include 5. So essentially, the domain of our first thing is not going to contribute anything because it's defined everywhere. But we do have to take out the value 1, and then we can continue again from 1 until we get to 5. So the domain of the entire thing is going to be from -∞ up to 1, union 1 to 5. And that's really all you do for these functions. You figure out the domain of each piece, you figure out where they overlap. It may be helpful to draw them out on the number line like I did, and then the domain is wherever all of the pieces are defined. So it's not enough for one of them to be defined or two of them to be defined. All of them, if you're in a three-dimensional function, all three of them need to be defined simultaneously. Otherwise, the graph doesn't exist.